Alright, I think I might be live now, maybe. Did I mute myself? Let's check all the settings. Looks like I'm good. Okay. Looks like we're ready to rock. Ready to roll. I guess I have to change font size because it's probably going to be a little bit small here. Maybe change it to like 24, something like that. Maybe that'll be right. We'll see. Okay. And maybe also the console font. Change that to. Yeah, I think that's probably looks viewable, at least on my preview. Okay. So, hey everybody. It's like the viewers is dropping rapidly. Not sure what that's all about. Okay, so let's start. Okay, so welcome back. Oh, there's an echo. Do I? Why would there be an echo? I don't hear anything. Not playing anything. Nothing's coming through on desktop. Maybe. Yeah. I mean, if it's not on GitHub, I always the rule is that I just forgot to post it, so I'll post it when I remember. So I don't know. That's very strange. Let me see. Yeah, I mean, if it's not on GitHub, I always the rule is that I don't hear an echo. Post it, so I'll post it when I remember. So yeah, I don't hear an echo. My guess is that you have two tabs open with the same stream or something. Okay. Now that I've used up 5 minutes of class for no particular reason, let's actually get to work. So let's talk about functions again. So yeah, I think that yeah, I don't hear it on my end when I listen to the stream. I also turned off my desktop audio. The only thing I have going is the mic, I think. Let's turn off all the other nonsense so that there's only one thing that can possibly make any noise. That's the microphone. Okay, so let's begin. So remember, what is a function, right? What is Yeah, that's possible. So what is a function? A function is a piece of code which can be called, and it runs, and then after it runs, it can return values to the location that called it, right? And so then you can set them into variables, you can print them, do whatever you need. So, no problem, no problem. Hey, I mean, normally I just keep myself on mute accidentally for the first like minute of lecture, and I'm just sitting there talking, and then everybody has to tell me that I'm muted. So at least I didn't do that this time. Yeah, so let me explain just for the record, as you know, not that sort of what happened to me. So basically, on Monday night, I drove home from lecture, and so lecture to home, tire fine. And then I was like, home to food, tire flat. So it was too late to go to a shop or do anything about it. So then what I did was I replaced tire. Spare flat. Right? So, okay. So now I take off both tires, take them into shop. This is yesterday. Leave them with the shop, And so I just called today, and that's why I was like a minute or two late starting class. Turns out they forgot about tires. So I just called them, and they're like, "Oh, we'll get to them. We'll do them now. We didn't know what they were." I'm like, "Yes, they are tires. They need to be fixed." Apparently, whoever wrote them up, the paperwork got lost, whatever. So whatever happened, happened. They were never gonna fix them. Great. So now they will fix them. So on Monday, I will be in person. With at least 4 to 5 tires on my car, right? Depending on the number of wheels that I end up with. So, unfortunately, you can drive with your spare, because my spare is not a donut. Yeah. No, this was just I don't even want to yell at the shop. They're usually good. They did a naughty thing this time. So, okay. Let's get back to functions. Yeah, so, yeah, 3 tires is, unfortunately, the way cars work is that you can't quite drive them on 3. At least, not the car that I have. It's a 4-tire car. It's a 4-wheel car. You must have 4. So, okay. Yes. So what's a function? A function is a piece of code that can be called, and after it runs, it returns the value. Technically, remember, you don't need to return a value. If you don't, the function returns null. Or, I'm sorry, not null, none. I was thinking C++ since I just wrote a bunch of C++ code. So yeah, it returns none in general. Okay, so then what else does it do? So it can take values. So when I say it can take values, what do I mean by that? What we usually mean is that you can pass arguments, which then become parameters inside the function, like that. And yeah. So, okay. That's enough of that for now. Let's talk about, let's get this done. So, so what on earth are we going to do? So let's do an example. Let's do a string replace function. So let's say that we get a new, so let's say that we get a string, and the first letter, right, and second and replace letter, right. Let's say that find letter, something like that, and replace letter. So remember that a function has to start with def, def, and the reason why is because it kind of stands for define, right? So we want to define a function. And so what we're doing is we're defining replace. Replace eats 3 things, right? And so what it's going to do is it's going to return a new string, right? So what are we going to do here? So we're going to do new string equals empty, like this. And then I'm going to do an if name equals name, like so. And then what I'm going to do here is I'm going to say, I'm going to call the replace function. So remember, to call a function, you use the parentheses. Now, of course, there's a slight problem with what I'm doing here, but I'm going to ignore that problem. So what happens if I do this? You know, it's a good question because you might see this error pop up. If you call a function and you notice that the number of parameters, so you see that what it's going to tell you might seem a little confusing, but it says missing 3 positional or required positional arguments, right? And all that means is, right, I wanted 3 variables, right? You didn't give me any, right? So actually we need to call replace with, like, hello, and let's replace all of the L's, right? Let's replace L's with Z's, right? And then let's print this, okay? So, what's the difference between null and none? The difference is that null doesn't exist in Python. None exists in Python. Null is Null is the C++ word for it. So yeah. Okay. I mean, it's not very exciting, but that's what it is. Every language sort of has their own version of it. Some of them call it nil, some of them call it none, null pointer, none, etc. So okay, so at least here this runs now, right? This runs. And so it actually will return values and execute, but it doesn't do anything. At least not yet. So, so how do we get it to do something, right? So let's think about how to replace things in a string. So basically, the way I would probably do it, at least, you know what? Let's do it a different way. I was gonna do it. So there's two ways that I was gonna do it. The way that I was going to do it is say something like this. I was gonna say for the character in a string. And I was going to say if the character is equal to the defined letter. And of course, the code what I was going to do in the other cases is very similar, so it's not going to be all that different. Then this is what I was going to do. I was going to say new string plus equals replace with else new string plus equals the character, right? So should this work? I think so, right? Because what we're going to do is we're going to go through every character in the string. If it's equal to the letter that we want to find, we will replace it with the whatever replace with is. And otherwise, we're just going to stick on whatever the original character was. If it wasn't the find letter, then we're going to just stick on the original character. So let's see what happens here. Let's see what happens if we run it. Nice. Okay, let's do it again. So replace, say, a man, plan, okay, now, Panama, sure. And let's replace all the A's with, I don't know, T's, right? Or E's. Who knows, right? It's not going to make any sense, but it doesn't matter. Right? Okay. And then, it almost like, it's a little strange. Okay, that's very strange. But whatever, doesn't matter. So, the function works, right? Mostly, at least. Let's try one more, replace. And then let me show you a different idea. So this is, I don't really know that this is teaching functions anymore once I do this other version. But, like, the point of teaching functions right now, like, if you ask yourself, what should I be getting out of this? What you should be getting is, here's a function name. I type def, I type replace, I type this colon, and then all the variables I need, I stick up here, right? Remember that new string is a local variable, right? It lives as long as the function lives. And so basically, new string, what should we say about new string here? New string dies here, but its value is returned. So the name, so basically the way to say it is the new string name dies here, right? But the value is returned. So the way to think about it is that there's no such thing as new string after the function returns, but there is such a thing as the returned value. So for instance, let's say, you know, my string equals, and then let's come up with one more thing. What's a good thing to replace? When once was in Westphalia, right? And just like the Treaty of Westphalia, right? We'll replace all the W's with Q's, right? I'm not sure that this is, you know, again, it's not very entertaining, but it is exact, you know, it's a function. It'll do what we want. So, okay, I guess we get rid of this comment since it does something now. So, you know, there we go. Cool. So here's something to talk about. Let's talk about function documentation just a little bit. You know, that'll take a few seconds. So if you use PyCharm, it'll autofill the documentation for you, and it basically says, like, so up here you want to say, this function will replace all single letter instances of find letter with replace letter, or with replace with. And then basically here here we would say string, right? That's really all we need. String, single character, string, same thing. That gets found, that replaces the find letter character. I mean, you don't have to be this detailed. And then return, what you don't want to say is return new string. No one cares about the name of the variable, right? So what you want to say is return a new string with the letters replaced, right? And so the idea here is that if you were some kind of, I don't know, programmer or something, what you could do is you could read this little blurb at the beginning of this function. You could say, like, you know, what if I name this function, right? As long as the documentation is right, the function's name doesn't really matter. Now, of course, you want to name the function replace, but maybe you don't exactly understand what it's replacing, or alternatively, maybe the parameters are like this, right? So if the parameters are like this, then you would like a description of what each of the parameters actually does, because notice here that x, y, and z are basically meaningless, right? You don't know what any of them are. Like, how do you know that the first thing you should enter is the string that you want to scan through? What if you want to enter the replace letter, then the find letter, then the string, or the replace letter, then the string, then the find letter? You just don't know, and the reason why you don't know is because it doesn't say. So that's why you should make meaningful variable names to give the next programmer hints, but you should also leave them a little bit of documentation. So on the first project, you don't have to do this in homework 5 when we get to functions, but you should do this in the first project. We will require that you document your functions. Now, do I require that you use any particular format for the documentation? No. If I see that you've used the format that PyCharm uses, that's great. If all you do, like, really, you don't even need all this stuff. Like, if you say this function will replace all single letter instances with blah, 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 right? That's probably fine. The only reason why I fill in the details is because PyCharm autofills a lot of this stuff for me and gives me a whole bunch of prompts, and then I feel obligated to fill them in. It feels like, oh, you know, I want to tell it all the things that it wants to know. The reason why you want this kind of documentation inside of your code is because it is very difficult for programmers sometimes when they're skimming, right? When you skim through code really fast at the speed of light, and you see a function, and you're just like, what the heck does that function do? I have no idea. And then you just move on, right? And the thing is, like, maybe that was the function you actually wanted to look at. Maybe that was important. Maybe it wasn't. So that's why we use documentation. Obviously, for a function like this, well, you know what? I'm going to say even for a function like this. The reason is that, you know, a function like this will get stuck inside of a big file with 100 other functions. And so it's kind of nice to have documentation that just kind of explains in English what the purpose is here. So here's another version. Let's do another replace function. And same thing, a string. What did I say? Find letter. Replace letter. So here's another way to do it. So here, what are we doing here, right? What we're doing here is we're concatenating. Every single time we're concatenating over and over and over. So this is actually a little bit inefficient because what actually is happening, remember when you concatenate, you're actually making a new string in Python, a new string. And so essentially what you're doing every time you concatenate is copying the entire string. So let's try not to do this. Let's see if there's a better way to do this. Right? Here's my other idea for a replace function. And you'll see why it's slightly better. So the first thing I'm going to do is I'm going to say string, let's say list of characters equals list of a string. Now remember what this does, right? What does list of a string do? What it's going to do is it breaks up the string into individual characters and gives you a list of them. Right, so the nice thing is that it returns you a list of characters, and then what we're going to do is say for I in range len list of characters, right, which is also the same, which is also the same as the list of, as the A string length. And then what we're going to do is say list of characters I, well, if list of characters I is equal to find letter, then list of characters I equals, whoops, replace letter. Else, nothing, right? So actually I think this is almost better. So here's why it's a little bit better in my mind. So it makes a list of all these characters, which the list will die at the end of the function, so actually it's not using up any additional memory. This is using up a lot of temporary additional memory, which also will get freed, but it could start using up a lot of memory. This one, on the other hand, will only ever use up basically twice the memory of the string. So you'll have the string, and then you'll have the list of characters, which is also a bunch of characters. So what you're going to have here is then you just return. Now what we're going to do is we're going to use our old string methods that we learned. So empty string dot join list of characters. Nice. And so we only actually create two. Well, actually, no, we only ever create one string here, right? We create this one string. Here, we're creating a new string every time we go through this loop, right? So we're adding on to the string once every time. Here, we're just replacing letters one by one. So this, I think, is actually a little bit better code. Nice, right? Also, you notice that you can get rid of this else statement. That's also kind of nice. Yeah, I think this is probably superior to this. But anyway. Okay, so, and then I'm not going to document that because I don't care. But let's check out and make sure it works, right? Let's at least check it, right? Cool. So that worked too. All right, so what's another type of function we can write? Good question. So, you know, I guess we'll write something like this. So let me just show you, let's remind you about how do you find the maximum, right? How do you find the maximum in a list, right? And so the way to do that is basically what you can do is you can say max index is equal to a list of 0, or I'm sorry, or is equal to 0. And then what you're going to do is you're going to say for I in, say, range len a list. I guess, no, let's do the for I loop, not the for each loop. The reason why I want to do the for I loop is because I want to track the index. And then what I want to do here is I want to say if a list at max index is less than a list at I. So here's the thing, like a list at max index may not be the actual maximum, right? It could just be a maximum, it could be something. So the point is that here what we're going to do is we will update the max. Right, so what does empty string.join mean? So good question, let's review. Let's say that if you do empty string.join, right, and then you have, say, like a list made of A, S, D, F, like this, right? You have a whole bunch of characters like this. Let's see, no, this function isn't finished. So remember that this is kind of a good use of pass, because you're like, I'm coding up this function, and I want to take a break for a second. So in order to take the break, so the point is here, if you have a list, and it doesn't even matter if it's a list of strings, right? If you join them like this, if you use the join function, it's just going to stick them all together. And remember that this is called the separator. So whatever goes in here is used to separate them. So if you put a space in there, it's going to separate them by spaces. If you put an X in there, right, it's going to separate them with, whoops, what'd I do? Okay, it ran. It's going to separate them with X's, right? Here's the X's, right? So basically whatever goes in here, if you use tabs, they'll separate it with tabs, right? So that's what the join method does. Okay. So let's go back to finding the max. So remember how to find the max. There's really two ways, I guess, to find the max. Either you could track the max index, or you can track the max itself, right? So let's write both versions. here's the max index version. Maybe we'll even call it like find max. Well, no. Okay. Well, let's call it find max. So here, what we're going to do is we're going to say something like a list. I'm sorry, no. Max index equals I. Right? So what is this doing? What this is doing is it updates max index to the current maximum, right? As far as we have scanned in the list. Right? So as far as we've scanned in the list, if I is the maximum, then we update the max. Otherwise, we don't do anything. And then what we're going to do is return a list of max index. Now, there's a slight problem with this code. The problem is that if the list is empty, this is going to cause some serious problems. So what we want to do here is you want to be careful. You want to say if not a list, right? Oh, have I talked about that before? No. So, what should I say? Basically this, but I think PyCharm wants to fix it. Right, let's see if it fixes it. Yeah. So, basically the way to think about this is, this line is equivalent to asking if the A list is not equal to, or is equal to empty. So a list, so any list will be true if it's not empty, and false if empty, right? So basically what this is doing is it's saying if the list is empty, then it evaluates as false, but then not false is true. So this basically says if the list is empty, right? That's what this is saying. If not a list is the same way to say if the list is empty. And so if the list is empty, we're just going to return. Now, technically in the future, when you learn about exception throwing and stuff like that, you might want to raise like value error or something like that. But in this one, we're just going to return like -1 or so, I don't know, return none. I don't know, something, right? Yeah, that'll work. And so basically the reason why you want to have these little if statements at the beginning of your code is because what they do is and this return value, what it does is that if the list is empty, it returns none, and then it doesn't run any of this code, right? So this is like a little safety valve. It says, if the list is empty, return none, don't do any of this. If it's not empty, then this if statement gets skipped, and we go down into this code. So, because of course you might say, like, what's the maximum value in an empty list? And it's a hard question, right? Because if you ask the question, what is the maximum value in an empty list, then the answer is, I don't know what that means, right? And of course here we're returning none, but yeah, so it's, as I say, what's the max value of an empty list? The correct answer is I don't know what that means, right? It's not just, oh, we have to think harder, or oh, we have to get more creative. The answer is really, it doesn't make sense to even ask that question. So this is one way to find the maximum, if you need the maximum index or care about the maximum index for some reason. Sometimes you actually care about the index as well as the element, but what if you just cared about the element? Let's write another one. Right? Find max element of a list. We're going to do the same thing. If not a list, return not. Right? Safety check. And then what we're going to do is we're going to say for x in a list, right? If x is bigger than the max value. Now, of course, you might be like, wait, what's max value? The answer is I haven't defined it yet. Of course, I put a semicolon there because I was just programming C++. I do my data structures class right before here, and I'd spent most of it implementing binary search tree remove, so I ended up doing a huge amount of C++ coding. So my brain is apparently still slightly in C++ mode, but whatever. So max value is going to be equal to a list of 0. So you set it to the first element. That's usually the best way to do it. You just set the max value to be the first element, and then you do this updating, and then here you return max value, right? And again, this line is the only line, right, that would actually cause problems. So all the rest of the lines are fine. This is the only line which would cause issues when you, what would we say? It's the only line which would cause issues when you have an empty list. But remember, if this line is a problem, which it is, then we need to have that safety checked above. Otherwise, we'll get an index error, and we will not be happy. Right? So that's the moral of the story, right? So you might say, like, what's the difference between these two methods to find the maximum? Notice here we're just looking at the value, so this is not an index, right? We're just looking at values. This is a pretty simple function. On the other hand, here we're looking at indices. We're doing a list at max index is less than a list at I, all that stuff. Notice that functionally it's doing the same thing, because instead of taking, for instance here, instead of taking max value is equal to a list of 0, we're just taking the max index to be 0. Now the max index, so keep in mind what the max index means, right? The max index is not the biggest index, right? It's the index of the maximum value. That's what we mean. Now, of course, you could say, what's the largest index? And that's a different question. But when I say max index in this case, I just mean what's the index with the biggest value. So what else should we program? Let's make a new function, right? So what's a new function to make? We always want to make functions. So, right? Oh, that's a good one, right? Let's do this. I like this problem. I like this problem. Okay. So basically, when I say rotate array, I really just mean rotate list. Maybe I'll even write that. The list, rotate list. When I say rotate array, it's so, okay. What should I say? Another word for list is array. Okay, good. Now that I've said those words, let us write this function. So what do I want this thing to do? Let me put the pass back. Let's say that I have the list 1, 2, 3, 4, 5. And I want to rotate it like this. I want to have 2, 3, 4, 5, 1. Right? Like, what if I want that to be what we do? Right? So, let's just say first, let's just do this without a count. So let's just try to do it once. Like, if we rotate this again, we'll end up with 3, 4, 5, 1, 2. If we rotate this again, we'll end up with, what, 4, 5, 1, 2, 3, etc. Right? So the idea here is we rotate the list just by kind of sort of shifting the first element to the end and then moving everything back by 1 or something. So that's what I kind of mean by it. So shifting everything forward, I guess. So here's what we can do, right? If you want to rotate, so let's say that we want to do this. This is our goal, right? So how would we do this? What we would do is we would write a for loop. We would say, for, say, I in range len the list, right? And then what we would say is, so here's one thing that you could try to do, but isn't quite right. So we have to think of a way to fix it. The list of I minus 1 is equal to the list at I. Now, and then we can return the list. Actually, we don't have to even do that, but we could. So let's see what rotate one position does if we do this. So keep in mind, this is basically saying the thing at I minus 1 is just equal to the thing at I. So let's see what happens when we call it on the list 1, 2, 3, 4, 5, and we print that out, right? Let's see. So notice what happened. So actually, it almost worked. The problem was that the so in Python, actually negative indices are allowed. So notice what actually happened here. When I was equal to 0, I minus 1 is equal to -1. So the list of -1 is the last element in the list, right? So that's not exactly what we wanted, because we got the right initial part, well, sort of. And what we did here was we said we shifted the 1 back, we shifted the 2 up, we shifted the 3 up, we shifted the 4 up. But then the problem was in the last position, right? The last element here didn't get shifted correctly because it was already replaced. So I guess we could fix that kind of easily by just doing something like, remember what the thing in the last position is, and then put it in the second to last position or something like that. Maybe that's the answer. So we could say something like last element equals the list at len of the list minus 1. Now, of course, you could could just say the list at -1. So that's legal as well. So you could say that, and then now that we know what the last element is, we can say the list at length of the list -2 is equal to last element. This is also not entirely correct, but we're getting closer. So the reason why this isn't 100% is because oh yeah, you have that Logitech joystick. Yeah, I haven't used it in a long time. It's actually just sitting in my mini fridge. Yeah. Oh, I forgot to put the broom away. The broom's still sitting behind me too. Okay. So anyway, what's the problem? The problem here is, of course, well, there's really two problems. So first, if not the list, we want to return the list, I guess, or none, or empty list, or something like that. So if the list is empty, we don't want to do any of this because accessing an element is a problem in a list that's empty. So we don't want to do that. The other thing we don't want to do here we need that the list has more than 2 elements. So here what we need is if the length of the list is bigger than 2, right? That's what we need to do. So if the length of the list is if the length of the list is just 1, then this will replace something with itself. So that's okay. And then so I mean, technically we could even do something like this, just to be a little bit more safe. We could do something like if the length of the list is right. It really doesn't matter. This loop will only run once and just replace an element with itself, so it's not actually going to... These two things are going to be the same because the element at position 0 is also the element at position -1 in a list of size 1. So, okay, let's see what this does. Let's see if this works. Look, it worked. Nice. So, yeah, 2, 3, 4, 5, 1. Good. So now, what if we wanted to rotate a list multiple positions, but we don't? So there's 2 ways to do it, right? Let's just write the list num positions, right? So here what we're going to do is we're just going to say for maybe. Let's see here. In a second. So what we'll do is for let's see, I in range num positions, and then what we'll do is we'll just say the list equals rotate list 1 position, the list, and then just return the list. There we go. So what this is doing is it's basically just calling the function a bunch of times and cycling through the positions. So let's try that out, and then we'll go back and actually try to understand the code again. Let's see, rotate list. Let's say we want to rotate it, say, 3 positions. Let's see what happens if we do that. Is that right? So let's look at that. So did this rotate it 3 positions? So this is the 0 position, 1 position, 2 position, 3 position. So it did it, right? So that's good. Nice. Okay. So what this is basically is an example of something like this. Is what we would call this is more like a helper function. Right? It rotates the list 1 position, but it also sort of just, but the idea is that rotating the entire list might have been hard, and I can show you how to do that as a separate thing, but say that rotating the entire list is kind of hard. So what you're thinking is, oh, well, I can rotate the list once, and then if I rotate the list like once and then just repeat that 5 times, then that rotates the list 5 positions. So that's exactly what this is. Okay, so yeah, so what we would say is that this calls the helper function. The helper function will rotate 1 position, right? Okay, so now how does this code work again? So the idea here is first, we have our little safety check, right? If the list doesn't exist, we just return, or I shouldn't say it doesn't exist. If the list is empty, we just return empty list, right? And the reason why is just because if we start messing around with an empty list, the first thing that we do here is we take the last element. Now, what that's going to do is, you see here, this is going to take the last element, the length of the list, minus 1. So it's going to take this 5 element here, right? That's what's going to be taken. And so because this is the element that's going to be taken, you know, when you have the list, length of the list minus 1, the idea is that this will be 5, and this will go into the last element. But if this was an empty list, then it would just die. So that's why we need the safety check. But anyway, okay, so now it's going to take the last element, which we noticed was the thing that, so how does this code work, right? So what this code is going to do is it's going to start with the 1, 2, 3, 4, 5 list, and then the first thing it's going to do is I is going to be equal to 0, right? When I is equal to 0, what it's going to do is it's going to say that the thing in the last position is equal to the thing in the position 0. So it's going to say the thing in this position is equal to this position, so it's equal to 1. And then it's going to take this list, and then when I is equal to 2, or when I is equal to 1, what are we going to get? We're going to get, so this is the list we start with. What we're going to do is it's going to say when I is equal to 1, then I of 0, which is the first element, is going to be equal to I of 1. So then what it's going to do is copy this 2 element back. Now the good news is it copies the 2 element back, but it doesn't get rid of this 1 because we already put the 1 in the right place. So now the 2's in the right place, so then it's going to advance again. Right? I equals 2. And so what it's going to do is take this 3 and put it back in position 2. It's going to take the 3 and put it back from position 2 into position 1. We're going to get that. Now, of course, it deletes this 2, but this 2 was already on its way out because we already copied it back here. So now let's do I equals 3. I equals 3 is going to say, at position 3, we're going to copy you back to position 2. So we're going to end up with that. And then, of course, the last thing that we do, now we actually don't even need to do this because, as you see, it's going to take something that's technically wrong and give us something else that's technically wrong. So technically what we could do, is this. So then it doesn't do this. Don't do this. But what it would do is it would take the thing in the last position and move it back to here. Now you see that both of these are technically wrong, right? Here we have an extra 4 and here we have an extra 1. So there's no reason to copy the 4. Oh, there's no reason to do this, right? Because we're already copying something that's incorrect. This is like a more complicated swap function, right? Shifting everything by a certain number of elements is a little bit like swap, which is why when you do a swap, you always need a temporary variable. So then here, what we're doing is if the length of the list is bigger than 2, we execute this loop. Here's what the loop does. We won't execute this last condition just because, I subtract 1. And then here, the length of the list minus 2 is just going to be the last element. And the reason for that is that what we're going to do here is at the end, we need to fix it, right? And the only element we have saved was the element that used to be at the end, which was this 5. And we just need to shift it here. right? We need to put it at 1 before the end. The reason why we need to move it is because it got destroyed during our first copy operation. So we just kind of let it get destroyed, and then we just remembered it, and then at the end we just stick it back in. So that's how to do it. That's what this does. Okay. Yeah. Okay. Here's another way to rotate positions. So let's do another path, another way to do it. So here we're going to say for I in range length the list, like this. And then what we're going to do is we're going to see how much we can destroy it first. What we're going to do is we're going to say the list at I is going to be equal to the list at what? So what we're going to do is, here's how we would have to calculate the position in the list. So what we're going to do is we'll say it's at the current position, which is I, plus num positions. But then that could exceed, right? I plus num positions could get higher than the length of the list. So then we have to modify the length of the list, like that. So that's basically how we have to do this. Now, you might say, wait a second. This is extraordinarily dangerous. Because as we do these copying operations, what happens, so we overwrite a bunch of stuff before we ever do anything like, so we're overwriting a huge amount of stuff. So let's see what happens if we rotate a list another way. Print, rotate another way, and let's try 1, 2, 3, 4, 5, and let's try 3 positions, right? So this should come out with the same thing, and it's going to 4, 5, 4, 5, 4. Right, so clearly something went horribly wrong. And what went wrong is basically that we're copying out of the list at the same time that we're overwriting positions in the list. So here's an idea of how to not do that. Right, so here's one way not to do that. Here's an idea. What you could do is you could make a new list. And you could just make it a copy of the original list. Now, of course, actually, we don't even need to make it a copy of the original list. It just has to have the same number of elements. The reason why it needs to have the same number of elements is because at every point that we have an I, we need the list I to work, and we need the list num position, plus num positions mod length of the list to work. So we need both of these indices to work, right? So if we need both of these indices to work, then the idea here is that we need a list of the same length. Yeah, it's a little complicated. But anyway, actually, there we go. So we just use that, and we just change this to new list, right? So, yep. So that should work now. Let's see. Yep, there we go. So you see that, like, this is a pretty, well, I guess there's 2 ways to look at complicated, right? Maybe it's hard to understand. I don't think the code itself is complex, but I get what you mean, right? It's hard to understand this at first. And so what you want to do at home, when you go home or whatever, or when you are home right now, is draw out a list and actually calculate what all these positions are and how it changes things, right? So basically when I is equal to 0, for instance, right, we're going to say here's our new list, and here's 1, 2, 3, 4, 5, right? So I list of 0, the initial position, is going to be equal to 0 plus, say, 3, right? So it's going to be equal to position 3. So we get 0, 1, 2, 3. So we're going to set that to 4. And then I list of 1, right? When I is equal to 1, we're going to say I list of 1 is going to be equal, or the list of 1 is going to be equal to the new list, right? At what position? At position 1 plus 3, which is 4. So we get 0, 1, 2, 3, 4. So we got that. And then, of course, what's the next one, right? So the next one is when I is equal to 2, the list at 2 is going to be equal to the new list at position 2 plus 3, which is 5. So, but the good news is that we are modding by 5, right? So basically the idea here is when I is equal to 2, this is the first time where the mod matters, right? We're going to do 2 plus 3 mod 5 is equal to 0, right? And so what that tells us is that this one at position 2 is actually the old list at position 0. So we get 1. And then here, let's do 3. Same thing. 3 plus 3 mod 5 is, mod 5 is equal to 1. And so the new thing at position 3 is the old thing at position 1, which is 2. And then finally, position 4. 4 plus 3 is 7, mod 5 is 2. So then 0, 1, 2, and there we go. Right, so this is an example of another function that we can use. Okay. All right. What else do we have to think about? What's another good example, maybe a simpler example, since I know rotating is kind of a bit of a brain twister. You feel like your whole mind is twisting around the indices instead of the other way around, so... let's think here. What's another good... what is the value of num positions? In this case, num positions is just 3, because that's the one that I used in the example. But, really, it could be anything, right? Technically, it'd be 702, but in this case, really, it's just 3. Of course, that's only because this, right? So if we did something like this, where we said, rotate this now 171 times, of course, rotating it 171 times is the same as just rotating it once, but, you know, who cares? So, yep. So that's how that works. Right, so num positions here is 3, num positions here is 171. Okay. What's another thing that we can do as a function? Good question. Hmm. I don't know. Kind of looking around for examples and books and stuff like that. Okay, let's just start a new example. So let's say the new example is going to be... We've already done one with strings. For a list of words, yeah, exactly. So the thing about it is that it doesn't actually... The thing about it is, what you see here is that nothing actually... Oh, well, you know, I can actually just prove it. Potato. Okay. Right, so in this case, it will do the thing. It will do the rotation regardless. So the thing to learn about this is that it doesn't really care what the elements of the string, or I'm sorry, what the elements of the list are. The reason why it doesn't care is just because we're not actually modifying anything inside the list. We're just copying whatever is inside the list at position I becomes whatever is in the position this other position. The only reason why I used 1, 2, 3, 4, 5 business is because that's, I don't know, the first list that I thought of that, you know, we can clearly see when it rotates. Because, I mean, you could also do a list like this. You could do this list. And then, of course, did the list rotate? I think, I don't know. The answer is like, yes, sorta, I don't know, right? If all the elements are the same, if a tree falls in a list and you rotate it, does anyone hear it, kind of thing? Okay. So, what's another good example of a function, right? So let's see. Let's get inspired, right? Any examples of functions that are good? Those functions are extremely boring. No, that's also so close to pointless that okay. Yeah. Gotta come up with one myself. The internet's not always the best place. So let's think of another example. So I saw one example that we could talk about. And this is actually a good example. Not because it's useful, because actually Python already has a built-in absolute value function that's called abs. So abs of x, you notice it's purple here. So, but what does the absolute value actually do? That's a good question. So let's input a value x, and let's say this must be a float or int, and let's return the absolute value of that number, right? So the trick here is that how does absolute value work, right? What it does is the definition of absolute value is equal to it's x when x is bigger than 0, and it's minus x when x is less than, or well, actually, it doesn't really matter where you put the equal, so I'll put it on that one, when x is less than 0. So the idea here is that x, the absolute value of x, is just equal to x when it's bigger than 0, and it's negative x when it's less than 0. So in order to compute the absolute value in a programming language, normally what you're going to have to do is you're going to have to say if x is bigger than 0, you'll return x, right? Else return minus 1 times x. And so that is the absolute value. So if you remember a few classes ago, I discussed what if name equals main is, and so what it is that there is a variable, right, that Python creates, right? So let me just print out name, right? So the thing is, you don't actually declare this variable. There's a few I'll call them like secret variables that Python makes. Name is one of them. I think another one is like doc, right? Yeah, doc string. There's a few of them, not very many, but the reason why they, and in order to make sure that you don't accidentally do anything silly with it, they add the 2 underscores instead of name, just to make sure that programmers don't accidentally like hit it, right? Like use that variable. Because I mean, how hard is it to be like, oh, name equals 13, print name, right? So that would be a bad thing. So if we print out what the name is, the underscore name business, what we're gonna see is that it's actually equal to main here. So so I know sometimes they talk about def main, but and what do I mean by they? Who is they? Sometimes you'll even see it in books, but a lot of times you'll see it on the internet, books, other sources. They'll talk about def main, but actually def main doesn't exist, right? So as a function, main is not, there's no main function in Python, unfortunately. What I mean by that is that you can create this function, but it doesn't actually work the way it should work in basically any other language with a main function. In like C++, for instance, here's a bit of C++ code. So notice that I have an int main function here, right? Basically in C++, this just means that the function is going to return an int value. The function's name is main, right? And it has no argument. You can have arguments for main, but this one doesn't have any arguments. And then here's some random gibberish code that you don't have to really worry about. Here's the end of the function. Notice that in C++, there's nothing here, right? There's nothing here that calls main. right? The reason is that in C++, your program starts by calling like the main function. So the operating system does this thing for you. They open up your program and they call your main function, and that's how your program gets started. In Python, it's almost the same, but the way to do that is this if name equals main business, right? So, def main is what some places will talk about, but as I say, it doesn't exist in the sense that you can make it as a function, but Python will not call it. Okay, so now, what if let's see, what did I make for draw stuff? I guess let's put this all in here. Let's print out name, right? Now, you notice that the name of the actual file is like functions2 return of the function, but actually it just calls itself main here. So how do you get it to not say main? What if I import draw stuff, right? If I import draw stuff, what it's going to do is this. Notice here, I had name printing out in the draw stuff file. And so since name prints out here, and then it prints out again here, what we actually see is when it imported the draw stuff file, it printed out this draw stuff name, right? So basically Python doesn't change the name. The name is equal to the name of the file, unless it is the main file, right, that is getting run. If you run Python 3 on like functions2, right, whatever, .py, I guess, then this becomes main. Right, so that's the moral of the story for main. Okay. So I'm going to comment that out just because I don't really want all that crap printing, but I'll leave the comments in, but I don't otherwise want too much of that. All right, so what's another function example? So we've done absolute value. So absolute value is a good little simple function, right? It just takes one value, and it checks if that value is bigger than 0, otherwise, It doesn't really matter, again, like you can multiply -1 by 0. The only reason why I don't like to do that is just, it just feels like it's extra work, right? Like, why would I force Python or your computer to multiply -1 times 0? Like, just let it return 0. Okay, so what's another good example of a function? Maybe another good example of a function is, say, let's look at a corner checker, right? On a 3D list, or 2D list. My grid, right? So what I want to do is I want to check to see if the corner values on this thing. So let's assume that it's a square grid, right? Let's assume it's going to be a square grid, which just means that it's going to be something like this. It's going to be like 1, 2, 3, or maybe like x, 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 y, y, x, y, 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 x, something like this. So it's going to be a two-dimensional list. The two-dimensional list is going to have, if it has 3 rows, it'll have 3 columns, right? So, yeah, so if it has 3 rows, it has 3 columns. That's it. It's just a simpler assumption for if it's a square grid. So let's try to see, and what are we going to check? Let's check to see if all of the corners are of the same type. So that means that all 4 corners of this thing are going to be the same. Well, let's assume it's at least going to be a rectangular grid. So we can be a little bit more general. So what I mean by rectangular is that it could be something like this, right? We could have like x, x, y, right? Something like this. And I don't know why I'm filling it in with x's and y's, but that's what I'm doing. This is at least rectangular. So the number of columns is fixed for every row. So there's not a different number of columns for any row. So that's one important thing to do. Okay, so now what we're going to do. So now let's talk about 2D lists again. Let's review a little bit about 2D lists. So what are the corners of a 2D list? right? Right, what indices are they? So if you have, remember that a 2D list needs two indices. It needs the row index and the column index, right? And so what are the corner indices in a 2D list? Let's go and talk about that. So first, the easiest one is probably 0, 0, right? The first row, the first column, row equals 0, col equals 0. So the 2D list at 0, 0 will be... Now, of course, you might say, but this isn't a valid name, so let's just change that to L2D. I mean, this isn't even code, but whatever. So that's one of them. What are the other ones? So the other ones are, well, on row 0, right? What is it? The column equals the length of row 0, or length of L2D of 0 minus 1, right? So we go 1 before we go to the last thing in the column. And then we have to go to the bottom. So what row is this? So this is the last row. This is technically row 2 here. If we put a bunch of extra rows in, then this will be, if we do something like this, and we do, right, this will be row 0, 1, 2, 3, 4, 5, 6. So this will be row 6, but then the point is there are 7 total rows. So what this is the row is equal to the length of the 2D list, L2D, of 0, or no, I'm sorry, just the length of the 2D list minus 1. The column is going to be equal to 0. And then the other position is going to be the length of the 2D list, and then the length of L2D of 0 minus 1. So these are the 4 corners of the list, right? So it's a good little thought exercise to go through and just to be like, okay, so now let's check to see if these 4 things are all the same. So the first thing to do is say num rows equals length of, what did I call this list? I have such a big comment here, my grid. I don't even remember. And then num cols is going to be equal to length of my grid of 0. Now this makes the assumption, assumes rectangular grid. Right? If it's not a rectangular grid, then the answer is that this is actually not correct because, well, you'll see, you might see why, but yeah, so you got to think about why. So, okay, now we have num rows and num cols, and so that's what these things are, minus 1. So now let's just do the checking. So let's say if my grid at 0, 0 is equal to my grid at, say, 0, num cols minus 1 equals my grid at num rows minus 1, num cols minus 1. Actually, you should put 0 first. And that's also going to be equal to my grid at num rows minus 1, num cols minus 1. So let's space that out. Now that it's on a separate line, let's do that. Didn't like that. Okay. So you can also use this backslash, or yeah, a backslash or whatever, in order to put yourself on a new line like this. I don't particularly like to use these. I'm using it here just for teaching purposes. I don't like these in general because what it does is it breaks this lineup, and if your code gets put through like a different text editor or something like that, these things are they're not very friendly. Like Python doesn't love them. I've seen them make errors sometimes, so I'd avoid them. Anyway, okay, so we'll just print out like they match. And then maybe we'll even print out what the thing is. So if they all match, then we'll print out my grid at 0, 0. Else we'll print out they don't match. And I did the same thing I always do, which is I make a single tick string with an apostrophe inside, and we can even return false, maybe return true. It's always good to return something. You know, if you have a function called check or is, like for instance, remember like an is palindrome function. Basically, I guess I'll say that as even more comments. Whenever you have a function, right? have a function. For instance, the function is called is blah, right? Or check blah. The answer is this should return a boolean, right? Because when you ask yourself, what is the answer to a yes-no question, right? The answer is yes or no. And for computers, that means true or false, right? So if you ever make a function that's called check or is or verify or whatever, like you say verify that this thing is a palindrome, check if it's a palindrome, is it a palindrome, right? Those kinds of questions should return a boolean just because, you know, it makes sense. So, okay, let's see what this produces. Let's actually run a few tests on this function. So let's see if this thing works. So let's call it on maybe a list. Let's make up a list, test list, is equal to, say, let's say 1, 0, 1, 1, 1, 1, 1, 0, 1. So let's call this on test list, right? And see what happens. So in this case, all of them are 1s, so it should match. But let's just see. Yep. And now let's make one that, let's say, that changes to 5, changes to 20, changes to 13. Now, none of this should change anything, right? So if we change all of these numbers, nothing should change here. Those should never be accessed. Accessed? Those should never be accessed. But if we change this to a 2, then the 4 corners don't match anymore, so it should fail. They don't match. Let's change this one to a 2. They don't match. How about changing 3 of them? They don't match. Changing all 4 of them. They match again, right? So that's just an example of a function, a little bit of a playing around with 2D lists, a little bit of understanding what the what corners look like in a 2D list. I mean, there's not, I don't think normally we talk about, I mean, talking about corners is a little bit strange, but it's a good way to get yourself to think about indices, right? That's the point, is you want to think about indices. Okay, so I think I have 1 minute left in class, probably even less than that, so guess what? Yeah, I have 40 seconds left, so that's a perfect place to end for the day. I will upload, I'll have to transfer this because I don't have the GitHub linked on my main computer right now, but I will transfer this file over to my laptop, and then I will upload yesterday's stuff and today's stuff. I will try to hold some online office hours tomorrow. I'll be around. I usually don't come in on Thursdays anyway, but I will try to be around on Thursday. And yes, the other thing to say is I'll see you next time, right? See you, you in person, very much in person. I'm sorry that I had to switch this lecture. It's like an emergency backup plan that I had. I didn't think I'd actually use it this semester, but I did because I had to. So I couldn't think of a creative enough plan to get to UMBC, but also fix my car today. Like, I couldn't figure out a way to get both of those things done. So, alright, thanks everyone. This video will actually be saved. It's a YouTube video once the live stream finishes, so you'll be able to watch it whenever. Yep, so if you missed it, you can always watch it. Of course, those of you who are watching it now certainly didn't miss it, and thank you for attending. Alright, so that's it for the day. I'll let you all go. Have a good rest of your day.